Good morning, class. Today I am going to discuss Module 2. Module 2 is whole numbers and place value. Let's start with the first topic. We know that algebra uses symbols and numbers that represents words and ideas. Let's start with numbers. Okay, class, you can see numbers written on the board. You can see 1, 2, 3, 4, and the 3 dots. These numbers are called counting numbers. Counting numbers is also called natural numbers. Class, the 3 dots here represents numbers are continuous, or the counting is endless, and it is called, the 3 dots is called ellipsis. Ellipsis is other term for saying and so on. 1, 2, 3, 4, 5, and so on. So that is what we call counting numbers or natural numbers. When the numbers starts with 0, 0, 1, 2, 3, and so on, they are called whole numbers. So the difference between whole numbers and counting numbers or natural numbers is that counting numbers starts with 1. Whole numbers start with 0. Counting numbers and whole numbers can be visualized on the number line, as you can see on the board. The numbers from left to right increases. The numbers from right to left decreases. 0 is the point of origin. If there is a point above the number, this is called the coordinate of the point. If ever the point is above number 3, the coordinate of the point is 3. Okay, take a look at these numbers. Identify which are counting numbers, which are whole numbers. So, yes, that's right. Counting numbers are 3, 15, and 105. How about whole numbers? Yes, correct. 0, 3, 15, and 105. Because whole numbers starts with 0 together with the counting numbers. That's why 0 together with the counting numbers. How about 1/4 and 5/2? 5.2, where they belong. So 1/4 and 5 and 2 are neither counting numbers nor whole numbers. So they are in between. That's why you can see them in either counting numbers or in whole numbers. Our number system is called place value system because the value of a digit depends on its position or place in a number. Take a look at this number. 5, 3, 7. And 7, 3, 5. Even though they use the same digit, the 5, 3, and 7, 5, 3, 7, the same digits, their value is different because of the placement of 3, 7, and 5. So, the value of this 5 is different from the value of 5 in the second example. Okay. So, take a look at the value of each number. Here, the value is ones. The second one is tens. Then next is hundreds. This is hundreds. So the value of 5 here is hundreds. So 100 times 5 is 500. So the value of 5 is 500. Here, the number is in ones place. So the value of this is 5. Why? Because 5 times 1 is 5. Can you identify the image? How many hundreds? There are 2. How many tens? There is 1. How many ones? There are 5 ones. Okay, so there are 2 hundreds, 1 tens, 5 ones. 2 hundreds is 200. 1 tens is 10. 5 ones is 5. We will add them all. 200 plus 10 plus 5 is 215. Now show the value of 215. First, we write the digit 215. Then, the place value. What is the place value of 2 hundreds? 1, it's in tens place. 5, ones place. Let's write the number 215. What is the value of 2? 100, because it's in hundreds place. The value of 1? 10, because it is in tens place. What is the value of 5? 1, because it is in ones place. Let's look at the total value. We got 200 by multiplying 2 times 100. 10, 1 times 10. We got 5 by multiplying 5 to 1. We add them all. 200 plus 10 plus 5 is 215. More on place value. We have here ones, thousands, millions, billions, trillions. Under each, it has 3 columns. We have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions, trillions, 10 trillions, 100 trillions. Now look at the number. What is the place value of 5? 10 millions. What is the place value of 0? There are 2 zeros. The other one is thousands, and the other one is 10 billions. What is the digit in hundreds? Correct, it's 1. What is the digit in 10,000s? You got it right, it's 2.